Hi all, welcome to our presentation. We are the Energy Pilots, and today we'll be exploring a challenge posed by the East Midlands Chamber to help tackle the rising cost of energy prices. We wanted to explore how we can inform the local authorities on how to enhance the power grid and energy consumption. So we have used public data sets with the goal of identifying weak points in the data set using previously unexplored parameters. And hopefully this challenge will be used to help inform local authorities on how to invest in infrastructure and how to take advantage of renewable energy. In order to build our solution, we have used data from three different sources. The Dukes, which has been an essential source of energy information since the 1970s, National Grid, network route maps, and energy performance certificates. These are all open source and available online, which makes it highly scalable and applicable to other areas. And in terms of analysis, we used Python to analyze the data sets, and then Power BI and Tableau to create visualizations. You can find our repository on GitHub, as well as the links to the Power BI, which are in the presentation. I'll now hand over to Ben to give a demo on Power BI.
Okay, so using Power BI, this is one of the visualizations that I made. So this summarizes the installed capacity of the fossil fuel types, so of the fuel types of fossil fuel and some renewable energy types for the power plants. So if you look here, for example, if you click on a fossil fuel, then it will show you natural gas, coal and diesel gas emissions, the amount, and you can see that those bubbles on the map are the largest, so they emit the most emissions, whereas for wind and solar, they are the most numerous, but they emit a lot less, hence why they are a lot smaller than the fossil fuel bubbles. And there's a timeline here too, so you can scroll all the way down and you can go all the way back to 1967, and you can set timescales too and see how many power plants there were at the time in the East Midlands area. And you can also, there's filters here, so you can pick the company that you want or the site name that you want too.
Okay, I'll now go over some of the analysis we were able to do on top of this data. So, as Ben has gone through, we have this really interesting data set of all of the energy production across the East Midlands. We also have via National Grid a map of the pylon network where the energy is being distributed around the East Midlands. And through EPC, we have a rating of businesses and are able to estimate how much energy they are using. Now, before we go into some of the more interesting stuff, one comment should be made on some of the data quality issues and data engineering that was required to get the data into the stage where we could start doing dashboards. So easting and northing is an uncommon coordinate format that is used by a lot of these data sets, and much engineering was required to convert this into latitude and longitude. Documentation was quite sparse on them, so it was quite hard to know what we were working with, and we had some various assumptions about averages and values that we had to take to end up with a reasonable result. But that result was that we were able to assess how much money was being lost per year by positioning businesses away from power generation facilities. This chart here shows us some of the potential money that could be earned through savings if we were to build a power generation facility near Leicester. We're looking at £1 million over a 30-year lifespan. With enough computation power, you could scale this across the entire country and start making strategic planning for the United Kingdom to reduce losses across the national grid.
Hi all, I am Jerome. I'm just going to give you a quick run through of the judges' questions and give you the answers that we actually came up with towards these three questions. So question 1 was, how easy is it for users to identify an actionable response for the solution? And that is very easy. The power consumption results dashboard contains the information. The hard part will be finding the right stakeholder and convincing them to action the results. For the question 2, how has the solution been designed to scale the additional data sets and KPIs? The graph shows that it can be used to analyze and work with multiple data sets when it comes to plotting a point for a new power plant to be developed. Also, with enough computing power, we can advise strategic decisions at a national scale. The question 3, how does the solution encourage data sharing? It shows the value that can be unlocked with novel thinking and access to the data. The graph also identifies that finding the correct plot of land to start development of a new power plant would become a great investment over a long period of time and increase savings. Not only would it be more profitable in the long run because of a significant reduction in loss of energy and waste, but also due to the location of development, it would lead to less maintenance, less fumes in the emission, and basically it would also cut down the fuel consumption costs. And that is the end of our presentation. So thank you very much for listening and have a good day.